we're looking at how to determine the vertex of quadratics, and some of this is not new at all. What we're going to do here is take what we already know and start building a little bit more onto that. So your warm-up question, first of all, is to determine the vertex of each parabola. And the first one, you'll notice they're all written in their vertex form, so it should be very straightforward to get the vertex. The second group of questions, they're written in their factored form, so there's a little bit more work involved with that. And then the third one is in their standard form, so again, there's even more work to be done with those ones. So try that if you have not done so already, and then so put the video on pause, and then you can press play again to check your work. So for the first group, because they're in the vertex form here, it's really simple. We're just switching the sign on the x, so that becomes an x. Take away 5 actually has an x coordinate of the vertex as positive 5. We could write that as an x plus negative 5. And then we have our plus 7 on the end, so that is our y coordinate of our vertex. For the second one, we're adding nothing to the x before we square it, so 0 is our x coordinate and negative 3 is our y coordinate. And here, I did have a little typo here. That decimal really should be here, but I think your version is corrected. This one has an x coordinate of negative 4, so it's x take away negative 4, and our y coordinate really is a plus 0, so it's a 0. So when you have your vertex form, you're just reading what we call the h and the k values from the equation. So I'm going to type that into that box here, and then you can look at the next section for your solutions for the factored form questions. So the vertex is going to just be h comma k when the equation is written in its vertex form. Y equals a bracket x take away h all squared plus k. Alright, determine the vertex of each parabola from the factored form. And what we talked about before is if we can find our x-intercepts, or if we make a 0 for the y, it's really our solution for our quadratic equation. We're going to get 2 values for our x-intercepts for this first one. 1 is the first one and 7 is our second one. We know that the x-coordinate of the vertex would have to be halfway between those two values so that we could so it will be symmetrical. So I'm going to take those x-coordinates, add them together, and divide by 2 to get the midpoint. So that would be 8 divided by 2, which is 4. And then what we do with that is we take that x-coordinate of the vertex, we sub it into the equation, and that will help us solve for the y-coordinate of the vertex. And I oopsed on that one. I meant to change that x into a 4, so we have 4 take away 7, and that gives us 2 brackets, one having a 3 in it, the other one a negative 3, so our y coordinate of the vertex is negative 9. So now we know the vertex is at 4 comma negative 9 for that. If you have not done the next two, try them. I'm going to put my solutions up. You can put me on pause if you don't want to see that. For the second one, I've got my x-intercepts at 0 and negative 4. And when I found the midpoint between those, I got negative 2, so that's my x-coordinate of my vertex. I subbed that into the equation and got negative 8 there, so my vertex is at negative 2 comma negative 8. For the third example, my factors are a little bit tougher, but not impossible. I found my two x-intercepts were at 5 halves and 7 halves, and when I add those together, I ended up with 12 halves, or 6, and then 6 divided by 2 gave me a 3 as my x-coordinate of the vertex. I subbed that into my equation, and I ended up with a negative 1 for the y-coordinate of the vertex. So those processes are familiar to us from our previous work. And in the box below, I'm just going to summarize the steps of getting the vertex from the factored form of the parabola. I'm not sure why every time I type in vertex it automatically changes it to a capital V, but it does, and I haven't bothered to correct that. So we'll just stick with it. Number 1, the first step is to set each factor equal to 0 and solve for the x-intercepts. Number 2, the x-coordinate of the vertex is just the midpoint of the zeros, or the x-intercepts. So you add those zeros together and then divide by 2. And then step number 3 is that we substituted the x-coordinate of the vertex into the equation to solve for the y-coordinate of the vertex. All right, so those are steps we already know from our work in our previous units. Likewise with number 3, if we want to determine the vertex of each parabola from the standard form, we used what we knew from our last unit, and we would take and put each one in its factored form. And then once we got it in the factored form, we could solve using these steps that we have up here. So for this first example, I'm looking for two numbers that add to -8 and multiply to +15. And I'll let you do that and try part B. You can put me on pause and then press play again to check your work. Okay, if you factored the first one, you should have gotten two numbers of -3 and -5, which means x take away 3 is one factor and x take away 5 is the other, which gives us our two x-intercepts, or our zeros for the related quadratic equation of 3 and 5. The midpoint of that is 4. Sub that in and you get -1. So our vertex for that one should be 4, -1. Now I noticed with part B, I had a common factor of -2, so I first started by common factoring -2 out of every term. That left me with an x squared plus 2x and a -9, which then I tried to find numbers that would add to 2 and multiply to -9. Now that didn't really go over so well with me because the only things I found were -1 and +9, or I could change that to +1 and -9, but in either case they don't add to +2. Likewise, -3 and +3 multiply to -9, but they don't add to 2 either. So at this point, what I'm going to get you to do is put that original equation into Desmos and see if you can figure out what the vertex actually is for that one. Okay, hopefully you checked it. I didn't actually put it into Desmos. I did a little bit of algebra, and I think if my calculations are correct, I think the vertex should be at -1, -7. Hopefully Desmos will confirm that form for you. So our goal here today is to actually find the vertex of each parabola, but there are cases when we have the standard form where we can't factor it over the integers. It's not to say it wouldn't factor, but we'll end up with crazy decimals or roots or whatever. So we need to come up with a way to get our vertex form from there. And that's where our next video is going to come in and the next page of our handout.